So that's one of the important things to look at is what electrolysis reaction will occur. Possible cathode reactions, let's say it's an aqueous reaction, a reduction of cation to metal, you could also, if it's an aqueous solution, the reduction of water to H2. So you have to always compare to that. If you have an acidic or basic solution, you have to look at H plus and OH minus as well. And another thing to note on this is when we talk about standard potentials, then you're not always at standard conditions. Standard conditions assume that you have 1 molar reactants. Now look, in this reaction, you got OH minus. So 1 molar reactant would assume that this reaction would have a given potential, the reduction potential of minus 0.83 at standard conditions. But at pH 7, when you have a lot less OH minus, it becomes less unfavorable. Minus 8.3 is pretty unfavorable, but when you reduce the amount of OH minus, then it becomes less unfavorable. It likes to form more OH minus. So an important thing is you can't just plug in the standard potentials if it's at neutral pH, because you have to watch out for those concentrations. Possible anode reactions, oxidation of anion to an element, Cl minus to Cl2 could be happening, but you also have to watch out for oxidation of H2O to O2. If you have 2H2O going to, you can oxidize the oxygen in water to oxygen gas plus 4 electrons plus 4H plus. And again, this is something that is negative 1.23 volts at standard conditions, but because it produces H plus and the standard potential is with pH 0, if you have a more neutral solution, then the reaction will become more favorable by creating more H plus. And so therefore it's not quite as difficult for this reaction to occur at pH 7. You don't have to drive it nearly as much as neutral pH as you would at acidic pH. You also have to watch out, for example, for oxidation of the electrode, particularly if you have a copper electrode. Other electrodes don't react that much. Graphite electrodes tend not to react more for kinetic reasons than the electrochemical reasons. So platinum probably is not going to react, but you do have to look at the electrode as well in many cases. Okay, so let's take a look at, let's apply these principles. Let's say you have a molten salt, molten sodium chloride. Well, there's really only one thing that could be oxidized, and that is Cl minus to Cl2. Na plus is not going to be oxidized anymore. You're not going to go down to Ca2 plus. So the only thing that can be oxidized is chloride ion, and so that'll be oxidized to chlorine gas plus 2 electrons, and those electrons can go to the cathode, and at that point, then the only thing to be reduced is Na plus, which will go to Na salt. Now, these are not particularly likely things to happen. Remember, sodium really doesn't like to be reduced. Chlorine doesn't really like to be oxidized. It would rather have those electrons. So you actually have to apply a fair amount of voltage for this to happen. Let's take a look at the tables, right? So let's go to our reduction potentials. So here we see chlorines right here, but this is chlorine reduction, 1.36. We want to oxidize chlorines. We want to run it in the other direction, minus 1.36. Let's take a look at sodium. Sodium really doesn't want to be reduced. It's at minus 2.76. So this reaction is minus 1.36. That's the E oxidation. And this one has E reduction of minus 2.76. So the total standard potential of the cell, assuming concentrated solutions, is going to be this is sodium is I had the wrong one before, minus 2.71. So the E cell is going to be minus 1.36 minus 2.71, 704, minus 4.07. You have to apply 4 volts in order to make this happen. But because there's nothing else to react, you have an inert electrode, so you have something that platinum or something that would require even higher voltage to start to go into ions, then that's what happens, because those are the only things you can do. So you just apply a really high voltage and you get chlorine gas and sodium metal. But what if we have something like electrolysis of sodium iodide? So in this case, to say, so now we have an aqueous solution. We've got sodium ions and we've got iodide ions. What is the reaction that's going to occur? Well, we have to look at what the possible oxidations are. One possible oxidation is iodide going to I2, which will, I2 ends up dissolving in water at low concentration. So there, the oxidation of this is minus 1.54, because the potential, if we just look at the reduction potential, that's 0.54. So oxidation is minus 0.54. And then the oxidation of water at pH 7 is minus 0.82. So what is the least unfavorable here? Well, the least unfavorable thing to be happening is the iodine. So if you apply a voltage here, you're not going to get oxygen gas being produced. You're going to get iodine, I2, being produced. So that's what's happening at the oxidation side. So at the reduction side, well, you could reduce the sodium to sodium metal, but that is pretty unfavorable. That reduction is quite unfavorable. On the other hand, the reduction of water to produce H2 and OH minus, if at neutral pH, there's again a neutral pH, not at standard state, that's a minus 0.14. Somewhat unfavorable, but not nearly as unfavorable as sodium. So the reduction with the least unfavorable standard potential is going to be the reduction of the hydrogen in water to produce H2 gas. So when you run electrolysis on this, you get production of iodine, and then you'll also get production of H2 gas. The sodium is just going to ignore it. It's like, I'm not even going to bother trying to take out any electrons. I don't want them. Here, water, you take the electrons. And so that's the reaction that happens. So the overall reaction would be iodide ion plus water goes to I2, which dissolves in water, plus H2 plus 2OH minus. And at pH 7, then you get a total E of minus 0.95 volts. You only need to apply that much voltage. If you have, there's two possible reactions on each side, assuming that the electrode is not going to react. If you had oxidation of water and reduction of sodium, that would require minus 3.53 volts. If you had oxidation of iodine, but then reduction of sodium, it would be minus 3.25 volts. If you had oxidation of water to produce oxygen, and then just reduction of water to produce H2, i.e. just electrolysis, you'd have minus 1.23. But that's not the one you'd get. It's the one that's most likely to happen. The one that's least unfavorable would be the first reaction. The oxidation of I and the reduction of water to get H2. Again, now one thing that comes up is this idea of overvoltage, is that sometimes reactions that do have the most that have the most favorable or the least unfavorable cell potential might not always occur. So if we look at possible, if we have sodium chloride now instead of sodium iodide. Sodium iodide, we got iodide as being the favored reaction. So at pH 7, then now the equivalent oxidation would be chloride going to Cl2, and that has a significantly less favorable oxidation. Because the reduction is 1.36 versus 0.54 for iodine. For oxygen, we would, so for the other possibility is to have water oxidized to O2, minus 0.82 volts. So the oxidation with the less unfavorable potential is going to be the water oxidation. So you'd expect to see water bubbling there. But what in most circumstances, the actual reaction is actually the chloride oxidizing. And that has to do with this overvoltage that has to do just with the specific interactions of water interacting with an anode. It doesn't happen in this particular case, and chloride gas is what you get. Is there a way to know that ahead of time? No, it's just, because of the way the cell is set up, you have that overvoltage, and the chloride oxidation ends up occurring instead. No way to memorize that. It has to do with the chemical details of exactly how the reaction is occurring. Yeah, variety of energy. So all of the energy losses has to do with some other reaction where you're losing enthalpy at some point, some side reaction is occurring. So this is the end of the segment where we've looked at defining electrolysis and solved some of the problems that you have that are common to occur, which is if you have some mixture and you apply a voltage, what is the reaction that's going to occur?